Good morning. Joe and myself will be presenting Spirit AEROSYSTEMS' journey of critical chain and how we've been implementing it within our propulsion structures and system business segment. Before I get into our presentation, I do want to take the opportunity to recognize one of our colleagues that are here helping us with our implementation of critical chain. Craig Bayless is the program manager for one of our pylon programs that we have been working with and applying critical chain to. So the agenda today, I'll be giving a brief overview of the company, the results of our implementation of critical chain, touch on a few lessons learned, and then Joe will come up and present how we're applying critical chain alongside with earned value. So Spirit AEROSYSTEMS was established in 2005 as a new company when Onyx Corporation acquired it from the Boeing Commercial Airplane Company. And at that time, we became our own company. Our headquarters is located in Wichita, Kansas, the air capital of the world. We also have operating facilities in Tulsa and McAlester, Oklahoma, Prestwick, England, Kinston, North Carolina, St. Lazare, France, and also Sumbai, Malaysia. In addition to those operating facilities, we have joint ventures with engineering in Moscow as a partner there, and then also in Xinjiang, China. We have a partnership there for spares and rework capability. So through all this operations, we're able to be a global provider of airplane parts and services and designs in a very large global market. Our product line is very diverse. Our mission is to provide high-quality, cost-competitive engineering, design, structures, and repair services to our customers. Fuselage segment is located in Wichita and also in Kinston. Our propulsion segment, which is the nacelle and pylon products, are designed in Wichita, and then in addition to those commercial products, we also provide services to our military customers as well through rotorcraft and fixed-wing aircraft. So let me go now into the journey that we've been going with critical chain. We've been implementing it within engineering. When we start a program, we establish what is our engineering statement of work and what is our duration for that. As we get into the development of our product, one of the things that happens or is part of development is that there are changes that come along. Information that is planned is changed on when it's available. So as those requirements, changes to criteria happen, the engineering statement of work and effort also increases. And as those new items come in, what it does is also affects our engineering community by increasing the WIP that they have to work with. So as the changes and new things come in, our engineers' WIP increases. And as that increase happens, that also affects our engineering activity there. One of the things that way we operate in an IPT environment. In order to get our inputs from our value stream customers and incorporate that into our product, so that when we start the assembly process that we have their input into our product. While with the changes that are occurring, that also affects that IPT environment. And that IPT environment also increases the effort that's required for the engineering statement of work and effort. So through that continual effort changing in that, our total time increases through our changes from the OEM suppliers and that, our resources and support that ultimately end up being a additional schedule and potential schedule delays as well. So if you take that for just one item, say like a surround structure for a fuselage, and you apply it to, okay, that's the surround structure. What about the skin, the cockpit, the nose landing gear, and all those other items? You can see where as you get those changes across multiple items within a structure, you get a larger or continual schedule delay, which because of the schedule delay, additional effort, we see an increase in our costs. And also, as the program progresses, we get additional requests from our partners or OEM on, trade studies, what-if scenarios that we have to go look at, and also weight reduction. So when you add that all together, we get additional creep in our statement of work, which with the schedule delays, the cost changes, and the increased statement of work, what we see is severe desynchronization in the way we were handling our product of engineering design. In order to manage that, we needed to manage our time, our costs, and our scope. So back in 2010, we initiated the objective of managing with critical chain realization on our programs, and then also implementing earned value. So we are managing time in that with critical chain along with costs. An analogy I like to share with you is like in a car, you have your speedometer, which is time, and then you have your gas gauge, which is your fuel consumption. You have to manage both. You can't just get in the car and just put your foot to the metal and drive off. You also have to manage how much gas you have in the car and that. It's definitely a requirement when you have a daughter that shows up late at night and goes, here's my car, and you go out in the morning and go, where's the gas? So you have to manage your speed and your costs, and also the scope. So to meet the overall business need, we implemented critical chain and also, along with it, earned value. So our implementation, we started off on new programs. The first new programs that we initiated this on was the C-Series Bombardier program and the Mitsubishi Regional Jet. After implementing on that, our next effort was focused on our sustaining effort, our Boeing product, our pylons and nacelle hardware, and then also our Gulfstream 650 hardware. Since that implementation, we're in the process of continuing our implementation on new programs, on a new pylon program and nacelle program that is beginning. And in addition to that, we've implemented it on our derivative programs on the 787-9 and also on the tanker program. So through the implementation on these two new pylon programs, here are some of the results that we have realized through the implementation. On the fan blade out unit, which is one of the first items that we deliver to support test activity, we were able to see an 18% reduction in our cycle time, going from a projected 17-month effort and completing it within 14 months in order to meet the customer's expectations. In addition to that reduction, we also have seen a 30% reduction in the planned assembly time of this piece of hardware. One of the benefits has been through our utilization of full kitting, and it was also recognized by our program manager for this program that has a lot of years of experience in the assembly area. His comment was, this was the easiest pylon to assemble for Spirit. So we were able to not only reduce time, but also be able to provide a quality product to our operations community for the building of the hardware. Another results that we realized was in our systems hardware. Traditionally, we design the structure and then bring in the systems. Similarly, when you build a house, you develop the framework and then you bring in the electrical, the plumbing, the heating, and the cooling. Well, that's our traditional or normal process for design development. While the customer had a requirement that we provide the systems definition and hardware prior to any of our pylon or structural components. So we implemented and managed with Critical Chain to be able to deliver our systems hardware 3 months before the fan blade out piece of hardware, and also 13 months earlier than what we had done in the past. So those are two benefits that we have realized on our first pylon program. On the second pylon program, we were able to recognize additional benefits through the utilization of full kitting. On that program, we were monitoring what are the requirements, what are the interfaces, what are the loads, and as we were progressing on, it was through the full kitting process that we did not have all the requirements to go forward. So at that time, we reduced our staffing and continue with a level of effort to develop that full kitting, ensuring that we had the interfaces, that we had the right loads and everything to proceed on, and to do it once rather than getting into the continual churn of second effort, third effort, and so forth. So through that effort, we were able to realize a cost avoidance of 20 to 25,000 hours. In addition, our cycle time, we are in the process of getting a cycle time incentive. Our customers asked that we deliver a pylon within 14 months. Our standard has been 21, but through the utilization of Critical Chain and the Concerto software, we're working to pull that back to the left so that to support their requirements for for our hardware on dock earlier than requested previously. And then in our sustaining programs, the way we have it is that it's just like a new design where we develop the conceptual development and then get authorization to proceed on with product definition. And in sustaining, we deal with two different types of items. One is fleet issues and then also production issues. And through utilization of Critical Chain, we have a 19% throughput increase compared to a 3-year average. So we're seeing benefits not only in our new programs, but also in our sustaining programs as well. So in summary, on our first pylon program, an 18% reduction in overall cycle time, on-time delivery for our first test unit. On the second pylon program, 20 to 25,000 hours of cost avoidance, and an increase of 19% throughput on our sustaining program. So how we got or went about to accomplish this effort was, one of the first things was the decoupling of engineering from our downstream systems, as depicted here. In the past, on our previous means of working on programs, we would develop a commitment dates in which we would put into SAP, and that is used to manage our operations. And then those dates would feed into what supply chain, fabrication, tooling, and then ultimately assembly for delivery into to our customer. So the first step was to decouple it and apply the 3 rules of critical chain in managing the engineering effort. And by decoupling it, we're also able to focus on what is the requirements that were needed for the systems. What is the requirements and effort required for the fan blade out and eventually for our production item. And by that decoupling, we're able to limit our work statement or our WIP. We're able to use buffering to manage it, and also buffer management in how we allocated our resources. So here's how we reduce WIP through the programs. We have a conceptual design phase, a preliminary design phase, and then a final design phase. So we reduce our WIP by identifying packages as depicted here in this illustration 3, and part of it is the full kit. Do you have all the requirements to do the effort? And we did that for the first work package 1 through 3, and then also for 4, 5, and 6 through the conceptual. Continue that on through preliminary design, and then through final design as well. And within each one of those work packages, we created sub-packages as well. And within that subgroup, we also created checklists going back to making sure that we had everything that we needed to proceed on and complete the project in the time that was needed. So through that effort of reducing our WIP, stagger our statement of work and our effort, buffering and managing our buffer, we were able to meet and obtain those results that I already presented. So here are some lessons learned that we have thus far. Full kitting has been a key item for us. We've made that one of our four rules. We have WIP, limit WIP, and stagger, full kitting, and then we go into buffering and buffer management. So it's become one of our primary rules that we operate with. Also, managing of the integrated product team. They are a key resource and critical by utilization of critical chain and the Concerto software. We're able to identify when those critical resources are needed to support the product definition. In addition to that, with identifying our work packages, we're able to group like parts. So when a bracket is designed, we provide a bracket of one design and what the design is, say, for 100 other brackets. But we also provide what is the bill of material and the requirements associated with that bracket so that our IPT members are able to focus on one item once rather than 100 times throughout a project. And then also one of the key things that has been very beneficial is the escalating of tasks. We found out that we need to pay attention to those escalated tasks and put urgency on it. In our implementation of escalated tasks, we felt like we were escalating and we got it, or was elevated to the appropriate level. And what we found out that as the buffer was being consumed, that we were not at the appropriate level to get the issue addressed. So it raised the awareness that you have to monitor those escalated tasks and that to get them addressed in a timely manner to avoid use of any more buffer and getting it to the appropriate level of management for resolution. So that's been our journey through the implementation of critical chain and Concerto software. I'll turn it over to Joe Zinacek, who will be going through our efforts on earned value.
We're going to go ahead and talk about earned value, and luckily Travis introduced it at the advanced workshop the other day. Our experience has been, we've been experimenting with it on one of our programs for like the last 3-4 months, but that's been under the radar, and the party line is that we're having a partnership between Spirit, Realization, and For Project to implement critical chain and earned value. For Project is a consulting firm that has earned value expertise, and so we've already had several meetings together, and but officially we're going to say it's going to start in January of the coming year. The 3 items there: we want critical chain to help drive schedule, earned value to help us with the cost, and then we're using Team Center for Systems Engineering to do our scope management. And of course, if all project managers know, those 3 are interrelated: cost, scope, and schedule. So that's our official program, and again, like I say, we have some experience last 3-4 months on one program, and we'll go through some of that. Just the basics. Earned value, some of you probably are more of an expert than I am on it, but the first thing you have to do is you end up with the green line is our planned, the blue line is the planned value. You come up with the planned value, and then the green line is what you earn, and then the red line is the actual cost. So comparing the red line to the green line, your earned value, you can come up with a cost variance and divide that earned value over the actual cost and come up with a cost performance index, CPI. And of course, you want the CPI to be 1 or greater. In this case, we're less than 1. Our earned value should be above that red line. We spent more money than what we got back in the earned value. And same with schedule, your plan or your earned value versus your planned value. And in this case, again, we're behind schedule. We don't have we haven't earned enough value up to the schedule where we're supposed to be with the planned value. So that's the real simplistic earned value basics. But like I say, earned value is somewhat, even for myself, a struggle. It's kind of, well, we're doing critical chain. We really don't want to do earned value. And the reason, I think, is a lot of people, there's possible conflicts. We're afraid that earned value will drive different metrics, or the metrics will drive different priorities. We may start cherry picking and lose sight of what critical chain is telling us. Possibly we come up with pressure on a task, we can't get through it, we may start another task because we want to get that earned value. So again, we may increase WIP without knowing it. And last, cost metrics might discourage resource concentration. And again, you may be stuck and you don't want to throw more resources on it. You're wanting to pull resources off when you're stuck, but maybe we need more resources, get through that problem and move on. So there is possible conflicts or perceived with earned value in critical chain project management. The criteria to run them both together, we'd like the buffer priorities not to be compromised. So in order to do that, we'd like our earned value work packages and our critical chain work packages to be the same. Thus, if we're getting progress on our critical chain, we're also getting the same progress on our earned value. Next, our cost accounts. We don't want them at a level that will prevent good resource sharing. So we want, for instance, if we get it down such a low level at the lead engineers, they may not share their resources due to their earned value metrics. So we don't want to get it down to such a detailed level. And again, the last bullet there is the earned value metrics should not lead to the following decisions. And again, these are straightforward. We don't want them to violate our critical chain. We don't want to decrease resource concentration, we don't want to increase WIP or their cycle time or compromise on our full kitting. So those are kind of like understood. So we have the criteria that when we're going in with earned value and critical chain for us here. So these are the steps that we did go through on one of our programs, and we have our sub-projects, work packages staggered out, and we allocate costs to each of those work packages. And then that's coming up with our planned value, and with that planned value we need it on a timeline. So we have our critical chain on the upper chain. We expand that out and come up with our earned value baseline timeline. So with our cost to the work packages and to the expanded critical chain, we have our planned value. So to get our actual cost, we have our work breakdown structures. This chart's kind of notational across the top, and we have our organizational breakdown structure on the left-hand side. And with our work packages, going through concept, development, preliminary design, and final design, we set up a control account, say around work package 1, and with that control account, of course, comes your charge numbers that we track the costs going into that control account and that work package. So this is how we get to our actual cost. And again, a lot of folks say that earned value is not complex, it's just a simple addition, subtraction, and multiplication. So that's where we're trying to head, get the numbers to do that, the calculations. So the steps of actually implementing, which you saw on the other slides, we're getting our planned value across the top, and then we're updating Concerto, and that helps us determine our earned value, and then from SAP we collect our actual cost. So with those, we develop our chart, the earned value reporting, as you saw and we discussed previously. There's still some discussion, a lot of discussion on the Concerto. Right now we have a simple spreadsheet. We take out the projected date and do some calculations to come up with what the earned value was. Again, the party line says that's maybe not pure earned value and not good enough. So we're still under discussions, and we have some work to do on that particular item in particular, especially. Last but not least is, again, you saw this chart in the advanced workshop the other day, but I'm not going to go in great detail, but basically we want to make sure the priorities are set with the buffers. So in other words, critical change should be primary and earned value subordinate to that. So again, when it comes up that the CPI is poor, then we need to go do something. And basically that means we need to go do some cost decisions, and that's possibly cut resources, cut timelines, do something to get our cost back on track. So ultimately the buffer priorities will be taken care of with buffers SBI, and CPI will indicate to us when it's time to take some cost actions.